Yo, yo, what's going on, everybody? Welcome in. Get your seats in the auditorium. Buckle up. Hopefully you're joining here because you're done with work. Joey, post-work at Kestava stream. That's right, come on in. Even if it's just for a little bit, maybe you're having a little dinner right now, or you're just catching it while you're moving on to the next thing on your list, but nonetheless, I appreciate you coming on in. We got a fun one today. I'm really excited. I got together this tier list that we're going to be diving into here today about structural engineering courses that you have to take in college, or at least I was going off of the criteria from the college I went to, so might be slightly different for all of you, but the gist is going to be the same. So we're going to go through those together, figure out what are the elite classes, whether that means to prepare you, or does it mean that they were the easiest or the hardest or the most engaging or just the most interesting? We're going to have a conversation, because what do you hold most important to rank things like that? So I think it'll be a good discussion. And if you're in here and you're not a structural engineer, or you're considering to be a structural engineer, well, this is a great background insight as to some of the stuff that you're going to have to go through to eventually become one. So don't think you got to go anywhere just because you're not a structural engineer. Got the water today. We're feeling good. And anyone here in the U.S., holiday weekend just kicked off. 4th of July. Let's go. So kick the feet up. You can stay a little bit longer this time because we got the big weekend. So looking forward to that. Any big plans for anybody? Oh, what do I want to start with here? I think we slap one over here. Let's start off with a little Wordle, warm up, let people kind of come in, let everybody just trickle on in. We don't want to start too early for the tier list. We'll get into that. And then I think I got some Revit template stuff lined up as well. So we got a whole bunch going on here today. Got the, I was thinking police. It was a stretch, I know, just out of nowhere. I know I used the H, but we're going to get some info here. There we go. Would it be? That's not even a word. Scratch that. I mean, I'm not going to beat around the bush here. Come on now. They wanted it. They knew they wanted it. So they clearly went with Pompey, right? Pompey? Nothing else, right? See, if I didn't have the courage to dive in right there, we would have had none of this information. Or is it... Is it Poppy? 3 Ps they're going to throw our way? Come on. Let's go. It's an easy one. It's an easy one, too. Cloud Blocker, welcome in. Poppy, there we go. That was without your help. Watch the eyes. Look back. Rewind the video. I swear. Let's go. What are your thoughts on detailing on Bluebeam? Not very friendly when changes happen. It's a little dark. A little dark. Hang on. Yeah. Maybe? Hang on. Maybe? Yeah, a little bit better, right? A little bit better. Actually, where do I want to put you? I gotta pop out the chat. There we go. Yeah, so thoughts on detailing in Bluebeam. I don't mind it at all. At the end of the day, it will come down to your contract. What are you obligated to deliver to your client? Is it drawings in Revit? Is it drawings in AutoCAD? Drawings in something else? So oftentimes what I'll do is, if it's a tiny job, like something really small, previous employers did this as well. They would say, okay, this job is so small, it's not worth our time to get drafters involved if you're with a big company, or just to get into Revit, create a model or a project, just to do these couple of 2D details and getting it out the door. So when it was of a small enough size scope, I would do the work in Bluebeam exclusively. And you'd have your little 8.5 by 11 sheets of paper with a nice template border around them that gives all the proper information. So it still looks clean, has company logo on it, looks good, presentable. But the actual drawing itself contained within each sheet was done in Bluebeam. And there's nothing wrong with that. It looks spectacular. It can look just as good, if not better than sometimes Bluebeam or Revit. But in contracts and stuff, what I'll do is specify drawings versus sketches. So anytime I say sketches, I'll say doing sketches in Bluebeam, review Bluebeam, blah, blah, blah. And that works great for small jobs. But you get out of that if you need to start doing coordination with architects and they have a model going and this, that, and the other thing, and you need big plan sheets to locate stuff, then you have to make that call earlier on and say, okay, this job is big enough that it requires Revit. I need to be a team player with my other designers, design disciplines, so I can't just Lone Ranger it with Bluebeam. On that note, though, a big switch that happened is the fact that pre-COVID, every drawing or every detail that you made was hand sketched usually. And then that hand sketch was transferred to a drafter, or if you're in a firm that doesn't have dedicated drafters, then you took that hand sketch and now you transferred that to Revit and made it into an official Revit detail. Some people did some Bluebeam there instead of doing hand sketches, but hand sketches were still really dominant. It's just that old school way of get your mind going, get a pencil to paper and just start sketching things out, erasing, keep it dirty on purpose so that people don't think it's a complete thought. Was actually one of my mentors kind of told me that, don't make it so perfect prior to it being done, because people can grab that and think that it's done for some reason, if it was added to an email and it wasn't supposed to be, or a contractor gets a hold of it or whatever, and think it's the done deal and it's over, but it might still be going through the thought process in your head and not supposed to go out yet. When it's done by sketching, sometimes that can be used as a fail-safe to be hey, it's clearly not done. But during COVID and then post-COVID, there's this big tide shift of how should we be doing work? Should it still be by hand because you were no longer in the office? So it was, you brought a sketch pad home with you, or a calc pad home with you, but because you thought you were only going to be gone for a couple of weeks or a couple of months or whatever, then pretty quickly your calc pad ran out of pages. So you were stuck with no paper, you couldn't go anywhere. So we had to turn to everything being digital. Or if you still had paper and you finished it, you're not handing it off physically to anybody. You're taking a photo, you're scanning it, you're doing whatever that you possibly can to send it digitally to someone. So many people had the intuition to go, well, I'm going to skip that step because it's cumbersome, and I'm just going to go straight to doing sketches on Bluebeam or digitally. And then from there, this conversation ensued on whether that was a good practice or not. It seemed like there was this split between age of engineer for some reason. The older you were, the more you kind of looked down on that process. Some people made the argument that the Bluebeam sketches looked so good, they looked finalized, that the engineer was spending too much time making this Bluebeam detail to then hand it off to the drafter to then make a Revit detail that was identical to it. But I'm not on that side. I was on the opposite side. What I still consider to be on the younger side of engineers, hopefully. And it was just, you're doing so much Bluebeam work that you get really good at it. You know the hotkeys. You have your little personal toolbox that you slowly build out with all of your grouped elements and everything like that. And you can throw together a sketch really fast. And on top of it, it can look really good. So, I don't know. That was a big discussion there. And it still goes on to this day. It's all good unless it starts crashing and 3 hours of markups is lost. Very true. Yeah. Bluebeam has a good system in place now. You know, we'll pop open the... Where we at? Let's get you over here. Give everybody a little... just settle down. You can start to take a look here. Start to digest a little bit. But I think Bluebeam, at least for me, has a pretty good failsafe now. Whereas if it crashes, when it reopens, it will tell you, like, hey, do you want to recover... We noticed you were working on this when it crashed. Like, do you want to recover this at the point of when it crashed? So that's a nice little fail-safe. That's always helped me out a lot, but you never know sometimes. For my company, it seems like we make the design engineers mark up on Bluebeam and then send to the drafting team to make on Revit or AutoCAD. Yeah, that's a common way to do it. Zach, welcome in. What would you do to analyze connections of non-standard framing styles? Specifically, I'm considering a project with the design of HSS connections using the Steel Tube Institute literature. And also, huge fan. I love that you're putting in the work to create a social space for design structural engineers. Hey, brother. Appreciate that. Appreciate that, my boy. It's the least I can do. Besides that, like, that Indian guy helping us all out in college on how to do statics or many, many different things, structural analysis when our professors couldn't. I just wish that I had somebody else or had more people that were in the space that I could branch out to and use as a collective home base of knowledge to help guide me on my path. So I always wanted that, and I hope that that's, at least with my channel, a place that can start to do that, and then inspire others after me to really kill it and have an absolute, like, blow up scene and have structural engineering or civil engineering in general just be the fucking place to be, man. Yeah. You were saying, what would you do to analyze connections of non-standard framing styles? I mean, if you do, I look back and I'm really fortunate that I'm in a part of the U.S. where I was brought up on, my firm did all the engineering for everything, just about. And the main part of that was connection design. We did all of our own connections in-house, engineering-wise, for all materials. So that built an absolute solid foundation for my ability to not be afraid of anything unconventional to a degree. There's always some scary stuff out there. I'm not saying I know it all, because I definitely don't know it all at all. But it you realize that there's not really anything that's conventional or non-conventional anymore after you do a lot of different types of connection design. You realize there's just... We're changing up this music. Yeah, all right, we'll go with that. You realize the material doesn't really matter that much. It does when you run the capacity checks. But overall, it all starts with just forces. Forces need to go from one area over to another area. Beam to a beam to a column, beam to girder, beam to wall, whatever it is. And then you have your starting point and you have your ending point. And then you build your load path, or you determine your load path and how it's supposed to get from point A to point B. And from there, you put plates, and you put welds, and you put bolted connections, and you put nails, and you put screws, and you put epoxy rebar, and this, that, and the other thing, and structural steel. And at the end of it, you have to justify your load path to someone and say, hey, this is how it's working. And then from there, now each one of your steps along your load path is something that you have to calculate. Is it the weld? Is it the yielding of the steel angle that's acting as a chair to pick up your tube? Is it, several nails that in shear that are connecting a steel strap to a wood post for tensile capacity and transferring tensile force across a joint, and blah, 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 blah. It goes on and on and on. So moment connections for HSS are scary. Yeah, they can be. They can be. I mean, you don't want to... You could do an HSS posts with a wide flange beam moment frame for smaller application type stuff. It's not too bad. You got your flanges to act as your force couple to take out your bending moment in the joint. And then you got your your shear tabs to pick up the shear demand at the end. And then it's one big happy family. You got compression, you got tension, and yada, yada, yada. So what would I do to analyze connections? Man, brother, I was taught by someone pretty old school, and it was do it by hand. Prove to me by hand how it works, step by step. Show me the calcs by hand, step by step, and once you convince me, then you can move on to the next one. And he was kind of a scary principal at times, and I mean that's how I learned and how I did it and how I still do stuff today for the most part. There's some things that I can kind of speed up a little bit nowadays because I've done it a bunch, but yeah, directly using material codes for your connection calculations is a big deal because it's all going to break down to, after you do your load path, to the material type. And I guess concrete has connection criteria per se, moment connections and stuff like that. But I'm more in my head thinking about like wood and steel, where in the steel manual that I actually have right next to me, because I was doing something by hand that I haven't done in a while, steel manual, you got, where are we? Part 10, there's whole chapters. Half this book is design of steel connections, pretty much. They have tables and figures of all shapes and sizes that you want to start to understand what they're providing you. And then in the back, you realize that, all of these chapters back here are all used to literally derive those tables in the front. So I shouldn't start using those tables and those values until I can derive it with all the equations that they give me in the back to get those very same answers that they give in the table. And then when I have that, I'm like, I know exactly what they're doing now. I have the confidence to grab those and make things a little bit faster, type stuff like that. Wood, they got chapters on connection criteria for screws and nails and bolts and concrete connecting wood to wood and steel to wood and main members, side members, all that kind of stuff. So it's a long road. Jack, woo, that channel member, part of the Peruka gang, welcome in. I feel like I can go really off the rails with connection design because I didn't realize that not everybody does it. And it's such a powerful thing to add to your collection of know-hows that I highly, highly recommend it to every structural engineer that they should be doing calculations for connections. And talk with your principals or talk with your project managers, and maybe you don't necessarily do steel connections because that's, subbed out to steel connection designer or fabricator. I don't even know who really does that for jobs where they sub it out, but okay, maybe not that, but maybe you talk to them for the next job. You say, well, could we consider this? Could we increase our fee a little bit to take on that work and do it in-house? Can we get the job done? Do we have the know-how? We can do it. Or try it on a tiny job. It only has a couple of connections. Okay. Just start asking. If you don't do it, and start to ask to be involved in it. It's a great boost in your engineering ability, and therefore it, I think, advances your career and your abilities beyond anything else. For atypical connection designs, I like this quote. To engineers who, rather than strictly following the codes of practice, seek to apply the laws of nature. To engineers who, rather than strictly following the codes of practice, seek to apply the laws of nature. I mean, it's a good quote. It is. There's many ways we have to follow the codes, obviously, but to explain it simply to one another in-house, I'm not saying per section 11.2-3, thou shall this, that, and the other thing. It's just like, no, okay. Like I was saying to Cloudwalker, moment connection, steel wide flange. Let's go live. Let's do it live. Hang on. We're doing it live. Fuck it. You got your HSS post. You can see that? Yeah. Then you got your wide flange coming into it. And this is going to be a moment connection. And so, oh boy, what are we going to do here? And you're, for those who know, your HSS tube. Well, commonly, we're going to take a plate, and we're going to have we'll say that this is the top of the column, top of the post. So we're going to have a cap plate that also extends out. All right, so we have our flanges top and bottom. And then why do we have those flanges? Or let's actually do this instead. We'll just say flanges top and bottom, and then boom. And then we'll put a couple of bolts in there. That's typically what a moment connection classically looks like. There's many other forms of it, but classically, we're saying. And it's like, well, why? Why does it do that? Explain it to me. Simply. Don't show me your 1,000 calculations. Just why? What's everything doing? What's the importance of everything? Oh, okay. It needs to transfer moment. And also, we know that there's, we'll say it's LRFD. There's a shear demand at the end of our beam as well. So we have, and we've determined just gravity. Well, sort of just gravity. It's not gravity. It's moment connection, so it's lateral. But we've determined that there's also no axial load on our beam. So usually call that PU, but AU equals 0. Okay, so we can ignore it. E. And we say, well, what's the first thing that we need to transfer over? The shear. Shear's the easy one. All right. Well, we know that the shear is in the web. So all the shear stress is in the web here. For any of you non-engineers taking a cross-section, your wide flange looks like this. All the shear stress hangs out in the web. And so what's the easiest load path to get the shear stress or the shear demand out into the column? Oh, let's put a shear plate on there and we'll do a bolted connection. We could do a welded connection, but we'll do a bolted connection because they want to, they say it's easier to erect in the field. Okay, great. So all of that shear force is going from the web into the plate it's going from the web, into the plate, the shear plate, and then that shear plate's taking it back into the column. Okay, well, that all makes sense. And now you zoom in a little bit more, and you're like, well, how does it get from the web to the plate? It needs to transfer from the web through each one of these bolts through shear capacity of the bolt. Okay, and then once it's in the plate, how's it getting from the plate to the HSS? Oh, well, it's going through the plate, so you need to check the plate for bending and blah, 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 and shear force, or in shear capacity, and then that plate is welded to the HSS. So we also need to check that weld, because the weld is the thing holding the plate to the HSS column. So that needs to be checked as well. Once that load path is all checked and all good to go, the shear force is taken care of. All right, what about the moment? How do we resolve the moment? Well, as I was talking about, there's a force couple. You always use force couples to resolve moment. Well, there's your force couple right there, top and bottom. And we know that bending forces or bending stresses compile in the flanges of our wide flange. And hence, this is actually why the shape of the wide flange or the I-beam don't, or look like they do. Each plate of, if you were to think it's made up of 3 plates, it's not. It's hot rolled and all that stuff. But each piece of steel serves a very specific purpose to combat certain stress types. And so we're left with this I-shape wide flange beam. But okay, so our bending stresses are tension and compression in the top and bottom flange of our wide flange, depending on the way that the beam is bending. And so you can get load reversal. All right, so if we know that they're hanging up top in the flanges, we need some type of connecting material to take those stresses from the flanges out into the column, just like same thought process we were talking about before. That's why we put these frickin' steel plates, top and bottom. Great. And so we have our moment, moment like that. And our force couple is gonna go bang in tension. Wait, am I doing this the wrong way? It's gonna... Oh, geez. Yeah, tension. And it's gonna be tension and compression at the top and bottom flanges. All right, and then from there, our flanges are welded to our steel tabs, top and bottom. You could do a bolted connection if you wanted to, if you so choose. You could make them look like that. Bolting the flange and the plates together, doesn't matter. It's just all dependent on the calcs that you want to run. And then from there, it's in the plate, and then you need to check the plate for a couple of things. And then once it's in the plate, then that plate is welded back to the HSS, and you got to check that weld to the HSS. And then you can technically, if the loads are big enough, you have to start checking local effects, things like buckling of the face of the HSS too, because it's hollow on the inside, and blah, 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 blah. So I already made that way too long and confusing, but it's like moment connection. You have shear and you have moment. The flanges are the couple that dump out your moment into a tension and compression force, and then the shear tab in the middle is directly dumping out your shear force. And there you go. Bing, bang, boom. It's done. Some of you out there might be like, well, I mean, if you're thinking about it, it's just like you're testing and you're messing around. And you have a plate here and a plate here. And you put your beam in there. And you weld this thing. But you don't put a shear tab in there. And you're like, okay, if I were to do this in real life, this would still stand up. It's not that there's no load path for the shear, or the shear demand, so this connection would fail. You're right. Some amount of shear force can get up and into these connections, these connected pieces, and work their way over, but it's a very difficult load path that the shear force or shear stresses don't want to travel to make work out. So ultimately, well, yes, you could erect this and put it in place and it would stay there. As soon as you start to see any real load, you're going to get deformations, and this connection overall is just really going to lack any type of shear capacity. So you wouldn't do something like that, because now all your load is just either in bearing directly onto this seat, and now that seat is like just bending because it's just a steel tab and blah 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 blah. Think about everything in connection design like or anything in structural engineering. Think about it like friggin' hard spaghetti and toothpicks and marshmallows and crayons. Think about bolts as like crayons. Anything that's really fragile to human touch, think about it like that, because you can become disconnected with all of these structural materials, because it's like, to a human, you can't damage any of this type of stuff, but an earthquake or a major hurricane or hundreds of thousands of pounds of dead load does affect this stuff, like a human can snap spaghetti, can snap a crayon in half with just your two fingers. So the force to the strength of these materials are much more closely aligned. And so oftentimes it can be like, oh, nothing's going to happen, it's fine. But if you think about it like being really, really weak, now all of a sudden you're thinking physically, and you're like, well, that's probably not the best idea to do it like that. I should do it like this. And to exactly that point, like, this isn't a great idea to have this bearing on this steel plate that's just cantilevering out from the HSS. You can do it. It's not going to be able to take a lot of load, though. It's going to bend. Oh, what's a better idea? Put a vertically oriented steel plate and connect it directly to the beam. Oh, that's going to be so much more stiff, and that's really not going to deform all that much when that load is transferring through it. The only thing, now I'm pushing on that, let's call it a piece of dry lasagna pasta. If I'm pushing down on that now, so all the load's going through there, what's the only thing that I might be worried about? Oh, I might be worried about that pasta plate, ripping out a chunk of itself along where the bolts are. And now you're like, oh, that's frickin' block shear, and that's all the principles behind that, and that's why we check that kind of stuff, and yada, yada, yada. So it's, try to keep it based in reality. Does that make any sense? I've been blabbering for a long time. Let's catch up. And I can see it now again. Is this a good time to discuss anything? Sorry, I'm new here and finding it really interesting. Juan, anything. Anything. I'm fine. Yeah, you can discuss anything. Why does NDS not have a table for a steel plate in the middle and wood on both sides? Double shear for bolts. What values do you use for this type of connection? Do they not? They do, don't they? Oh, do I have the... Oh, hang on. Hold up. Wait a minute. Wait a minute. Yeah. Oh, it's green screened. All right, let's check it out. We good? We good? All right. Oh, actually, do I have one? Hang on. This could be even better. This could be more interactive. Oh, we already got fireworks going off outside. Oh, it just got so bright. Alright, there we go. Let's see. Where do I want to go? See, I have all my tabs, so it's like more quickly for me. I thought there was something. Am I tripping? Um. 91. So you have your Z tables, single shear. I could have swore, can you guys see this all right? Yeah. I could have swore they had double shear conditions. Do they not? Single-sided. Single-sided. Double. Double shear, 3 members. It's bolts, which makes sense because you're not going to get nails to work out that way. Yeah. Here you go. Did you say steel on both sides? What'd you say? Now have a table for a steel plate in the middle and wood. Oh, the opposite. I see. So flip this. So wood on both sides and steel in the middle. Like a, what is that? A filch plate? Filch beam? Flitch beam? I don't use those. What was that one? Oh, glue laminated. I mean, yeah. So you'd have to run your own. Ugh. Oh, I didn't want to save. So you are looking for, if I can draw it. Boom, steel. And then, I mean, it's like kind of usually the opposite. I'm not, definitely not saying that you can't. So that's wood. The red is wood. And the green is steel. Okay. Like a flitch plate. Okay, technically they, and then you'd through bolt it. Like that. And then this is the bolted side. Or bolt head side. I don't think the pictures could possibly get any more. See, this is what I send. When I say that I do sketches in my contracts, this is what shows up. And I just go, whamp, with a nice little, this is my organ stamp. Giving a nice little thumbs up. And there you go. That, in case anyone wasn't sure, is the Oregon structural stamp. Don't use that. I just got doxxed. Don't use that. That one's my personal one. Don't use that. That's what some people try to submit. No, I would never submit this. Yeah, wood on both sides. Yeah, so... I mean, shit, your steel ain't going nowhere. So it's really just your wood. Yeah, so you gotta run those numbers for bolted connection. Wood being your main and then steel two sides. Or no, steel being the main and wood is two sides. Huh. Interesting. Yeah, I feel like they could use that in there. Maybe we cook something up for the boys and the girls in the chat, guys and gals. Is there... I gotta look up a design document for a... I still don't even say it right. Flitch plate. Everybody know what we're talking about? Flitch plate? Move you over. Go to the images. There you go. All there is to it. Yeah, I haven't done one of these yet. It never comes into play for me. Where I'm at, it always pivots over to like sandwiched LVLs. So a built up LVL, or you go the glue lamb route. I don't know if that's just because of where I'm located and the availability, but I haven't done one of these. Oh, there you go. That could be there's an application. That I have done before. So I have done it in my past. Yeah, it's a nifty little one, all that hidden connection. That's a good one. I love to see what it looks like in the wild. Like that? Is that one? Why did we... I don't know why we're notching those. That's fine. I'm missing something. At least it's notched at the end where your bending demand, so your tension stress at the bottom of the joist isn't high. Anyway, I don't want to rage over online pictures from Google. LeVar, welcome in. Snipping my sign right now. My stamp? You can't. How do I protect this? Wait for it. There we go. I forgot you can get this little add-on to your stamp. Bang. Woo! That was a close one. Sorry, everyone. I know you thought you were going to be using that. Looks like the joke's on you. It's not all about Revit. Revit's going back to their roots, okay? It's really what's happening here. Lindapter, hollow bolt for HSS connections. Oh, I've seen those before. The Lindapter, those are like to be able to put the bolts in the hollow tube, right? Yeah, I've had a lunch and learn on these way back in the day. Yeah, so here is a company that said, all right, well, we know that contractors love to bolt things and they hate to weld shit. And so you can get away with, I deleted it, but you can get away with doing a bolted connection for the shear tab for the web of the wide flange to the plate, to the shear plate. But that shear plate always needs to be welded to an HSS because you can't do a bolted connection to the hollow tube. You can't get inside of it to secure the nut or whatever. And so this company said, screw that. I bet you we can figure something out. Why don't we do something like we do with, drywall anchors on absolute steroids? And that's what they did. Because this connection, or this bolted connection, this type of bolt that they're going with here, this like flared, like wedge anchor-esque design, I believe it's really only used to transfer shear forces. I think its tensile capacity or pull-out capacity isn't very large. I haven't used them, so I don't want to knock Lindapter and have their lawyers come after me, but that's commonly the same for any type of connection of this type. When you have these flared wedge connections, if you think about it like wedge anchors in concrete, they're not very good in tensile and pull out. They can transfer shear forces really well, but they're not anywhere close to comparison of a tensile capacity of like a cast in place anchor. I'd say this is probably the same thing, which works for the application of the shear plate because it's only supposed to be transferring shear forces. So that checks out. While your webs top and bottom are still doing the work of transferring the tension and compression resultant forces from the moment. But yeah, these are cool. Oh, look at that one. There you go. Here you go. Here's that hand sketch, and it's on engine tips, so you know it's all going down. There's something that the used to be, even myself, what I did pre-COVID, that was what things looked like to a degree. I think I made my sketches a little bit nicer, but sometimes when you're in the heat of the moment and you're flying with a deliverable, they can look like that. And you hand it off to the drafter and you say, please make this a reality. But this is how, even if you're not sketching, this is how the conversation starts. If you're talking with a project manager, you're talking with another design engineer, ping-ponging how you're going to make a connection work out. It starts with something as simple as that. Who is this? Wait, you guys know who this is? How do you know this? I'm missing something. Hey, Kestava, I graduated about a year ago, and I'm struggling to get a civil engineering job. Any advice for me? LeVar, what type of job do you want? What sector of civil engineering are you looking for? Civil engineer, structural engineer, geotechnical, transportation, environmental, something else, contractor? Let me know, dog. What are you thinking? Juan, the plan checker has asked me to ensure the continuity of a ridge board. Okay, like a ridge beam, but it's a board because it's a triangular roof. So it's not a vaulted. Do you see it as necessary? I mean, the ridge board is a non-structural element. The plan checker has asked me to ensure the continuity of a ridge board. I mean, I think it's a good thing to make sure that the ridge board is continuous, and if there are breaks in it, then they should be stitched together. But yes, if you're talking about a ridge board, not a ridge beam, and I know you're talking about a ridge board because you said board, then I think it's a decently quick fix overall. But I mean, hey, the plans examiner, what they want, they shall receive. You don't want to get anybody on bad side of things. They're just trying to make sure that everything is done appropriately as well. Sometimes you get some people with some of their own vendettas that bleed into it, but just being nice and staying nice, and it will only help you. Don't try to act all high and mighty with plans examiners. It never works out. What are your thoughts on masonry design? I like masonry. I actually really enjoy masonry. I had never done it before until studying for the SE. You guys know this, I know, but once I started studying it, I came to enjoy it a lot. So I've done designs now with masonry, and they've gone well, and I like the calculations. I like the code that they have. The code's a little vague, but overall, I think it's a cool material. It's just shittier concrete. It's what a good buddy of mine who's a master of concrete always used to say. So that's what I'm gonna keep in my head to this day. Juan, the ridge board can provide stability to rafter top connections along load path axis in certain load conditions. There you go. Zach's on it. MS Revit. Oh my goodness, I like that. Certified. MS Revit, baby. I think we're gonna save a ton of money. This is just a cost savings practice that we're going. This is just cost saving, hurdles that we're going through, and voila. Welcome to Revit Extra Light. Diet Revit. Revit MS. Doesn't get any better. Axes. Anyone here use Open Bridge Modeler? Or Open Bridge Designer? What we got? Open Bridge Designer. Oh, look at this. It's a Bentley product. Run for your life, people. Looks neat. I know that there are Open Bridge Designer. Anybody been using this? Doing an internship and working on highway bridges, structural design. Nice. What's the Shuriken connections? Shuriken connections. Oh, I've seen this exact pamphlet. Whoa! Better bolted connections. No field welds. Faster installation, more savings, more uses. No downsides. Look at these this animation's sick. Step 3, field bolt the adjoining pieces. I mean, at this point, it's just Legos on steroids, which I'm not against. Whoa, what is this? Simply tack weld shuriken to metal plates in the shop. You got the lawyers out for this one. No field welds. But there are still welds. I get it, it's tack welds and it's in the shop, but... Step 2, install the metal plate to one piece of HSS, speed core, or other material. That's neat. They are cool. I'd love to see it sometime. I wonder how... I mean, all these products usually... It's a jumbo HSS. Just a big boy. Steel pipe piles. Join Doug Ford. Huh. Looks like he's stealing my secrets. All right, Doug. We're watching you. For engineers. I bet you they have like shit tons of pamphlets and information and of exactly like baby step spoon feed how the engineer can spec it and use it and make sure that it's adequate. That's usually how they get you. That's how like Simpson has really grown strong over the years of just making it so simple to use from the engineering perspective to calc things out that it's just like a no-brainer to use them. Where we at? Is that a Coot K original? Okay, so this is the... Who's this Coot K? Person's a legend. Just a guy who posts all the time on engine tips. Oh, okay. It's a prolific engine tips contributor. Coot K. Oh, well, now I gotta. Now we just gotta. It's from California. Damn. What do we... Let's go... I don't know. I'm just gonna click on that. Huh. I don't even know how Engine Tips works. Okay. Refers to a well-regarded contributor on the Engine Tips forum website, known for his expertise in structural engineering, particularly in concrete design. Slab design. Wow. We got a big timer. That's cool. Oh, there's a shuriken. Ah. Oh, so this is like, okay. So I can see this in... it's looking like pedestrian bridge type stuff. Oh, there was just a photo of one. Huh. Cool. Yeah, here you go. Some trusses. HSS trusses. Neat. Oh, you can even get away with that. Ah, my goodness. So handy. So optimized. So convenient. Coot K will find a mistake in anything you post on Engine Tips. Well, Jesus, if he goes to my channel, he's going to find a bunch of mistakes. But... Coot got us all through at least one class in undergrad. Okay. Motorhead, welcome in. Welcome. Frank Sonata, welcome in. What's going on? Grab the seat in the auditorium. We're about to kick it off. I know I've been chatting for a little bit here, but I think it's go time. Lewis, welcome. What can you say about sheet pile design? Sheet pile design, I had to... Oh boy, did I do sheet pile design? No. We did H piles and we did drilled H piles with, what's the timber? Is it timber lagging? Is that what it's called? Timber lagging shoring. That's what it's called, right? Yeah, timber lagging. Yeah. Yeah, I did like these guys. So the H piles, driven H piles in concrete casings, and then timber lagging installed. I think I had to look at sheet piling at one time, but I never had to pull through with it. Is that sheet piling? Soldier pile walls. Are you trolling me? I knew what that was. Hadouken. I knew exactly what that was. Ay. Atlas Tube makes crazy steel stuff. I question that connection in Slender. Slender columns. Yeah, I feel like in Slender columns, you're going to start to just be limited in space in general. To like shove all that stuff inside of a Slender tube. I only use Hilti because I like their software more. Hey, sometimes it comes down to that. Yeah, Hilti Profis. I use Hilti most of the time as well. Are we... Yeah, we're good. Hilti's a bit more conservative on the capacity side, 1 to 5%, so great choice. What do you think about using through bolts on hold downs in existing concrete foundations in place of epoxy connections? Let's head to MS Revit. I've had to do this before, and when you need the capacity, and it's not pretty, and it sucks to build, I would assume, but this was on a seismic retrofit job, but you have an existing stem wall, and then you got your wood, and you have your hold down post, and then you got your new hold down, whether it's because this is a new shear wall that we've added or we're adding hold downs to existing shear walls that didn't have hold downs before, or whatever the case may be. And you need more capacity than just to drill an epoxy. And because post-installed anchors can only provide so much tensile capacity, which is the main thing that you need for a hold down for a shear wall. So, because of that, the only other option that we did, at least, was... It's a little skinny at the top there, but I'll go red here. We had them drill out... You know, if it's a 7/8 inch diameter steel rod, then it was a 1 inch core that they drilled out. They dropped that threaded rod all the way down, and then at the bottom we had them put steel plate and then hex-headed, or then an anchor bolt on it, and fasten that to the underside of the foundation. And they had to dig out underneath to get to this location so that they can put their hand and tighten that bolt, which sucks. I know, it sucks a lot. And then they came back and they poured a concrete slurry to encase it so that it doesn't rust and degrade over time. It's that sealed solid. But that was one way that we had to do it in order to get the strength that we needed. And then they backfilled back up, and then they poured the slab back over and called it a day, kind of thing. Sometimes this is too invasive in other areas where it was like, no, that's not good enough, or, excuse me, in situations where you only needed to upgrade the hold down or add a hold down, but the foundation was adequate and the bearing capacity was adequate, this is where we had to do this. In other instances where the foundation was inadequate, you just tore all this out and you just made a brand new design with a wider foundation or whatever you needed, thicker foundation if you needed more overturning, combat overturning with some additional dead weight, and then you can just do a normal cast in place hex-headed anchor bolt and do your normal hold down that way. Some others that I've seen, I believe, is like, what have I seen? I think I've seen upside down, like, saddles. So steel plates make an upside down U, and then they through bolt those into these stem walls. I believe I've seen this before as well. So that's an option. Again, it'll depend on what your demand is. And this goes all the way back earlier to the discussion that we had on connection design. It's just, someone might say, oh, the green one looks really weird to me. I never see him do it like that. Or the red one that I did here looks funny to them. I haven't seen him do it like that. But just because something sometimes can look weird, if it looks really weird, yes, can sometimes be a little alarm bell to say, hey, let's talk about this. Why are you doing what you're doing? But just because something looks maybe a little funky doesn't mean like, oh my God, there's no way in hell I'd ever be able to figure out how much that can hold. You get the forces and you start with your load path, and then you start doing all of your failure modes. You know, is it the weld? Is it the plate? Is it the plate and bending? Is it pull through of the anchor? Is it this, that, and the other thing? Blah, 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 blah. And once you prove all of those things and you show that the numbers work, you can get other engineers and contractors on board to say, oh yeah, this is a viable solution. It's engineered to work. I'm proving to you that it works. Where am I? Vishnu, welcome in. Hi, I passed the FE Civil, looking for an entry-level structural engineering job. Do you know any openings anywhere? I am living near Salem, Oregon. Oh, very cool. Do I know of any openings? Not at this point in time. I know that they're out there, but I'm not looking, so I just haven't, my eyes haven't crossed paths with remembering things like, hey, this is an open position or whatever, but I'd reach out to companies or go to their LinkedIns or whatever and see just do a Google search, see what's popping, see what's available. Fell for that one, yeah, I did. Realm Elements versus Risa 3D. Oh, I'm not even... This is where I get off the rails with any type of knowledge that I can say out loud to all of you when it comes to structural analysis software. It ain't me, dog. I just don't have that expertise. I know me some Risa 2D. I've done a little bit of Risa 3D, but even still, that's been a little bit. I really want to be getting into more ETABs. I had to do some more major ETABs a little while ago, but I'd love to just work on model after model after model for practice to get better acquainted with it. Something I always dodged. I guess I was doing hand calcs for all of the connections, and I missed out on doing all of the crazy structural analysis stuff. Look up Williams S9 undercut anchors. Only post-installed I've found that can get good loads. They'll develop these bolts. All right. What's it called? Williams S9 undercut anchors. I'm trusting you. Who said this? Charles? I'm trusting you. Nice. I knew it all along. I knew I could trust you. All right, what are these? What are these? What are these? They look like wedge anchors. Am I tripping? Are they just big boys? Big boy wedge anchors. Really? J-bolts. Ah! Get away! Really? Do they have... Let's go to the... How big are these? Cyclical loading in cracked concrete. Vibratory loads. Huh. Can you guys see my dog right now? Alright. He's gonna get let out. And I need a water. Quick break. Quick break. Quick break, and then we gotta, I swear, we're starting a tier list. So this is what I'm gonna do. We're gonna go. What are we gonna do? What are we gonna do? What are we gonna do? We're gonna do this. Bang. Tier list up. Get ready. And I'll be right back. Whatcha? We're back with sad music. Where's our music? There we go. All right. Big Pencil, welcome in. Love that name. Any updates on the CBT SE exam? I know we're a couple test cycles into it now, and I know several states have written to the NCES board about it. Any updates? Like, does it suck less? Probably not. Although, actually, I have heard it's improved slightly, just with the mechanics of how things work, but dude, it sucks. It's so bad. It was a Hail Mary that I passed the CBT. Good. I hope states do write into the NCES, because I think it's garbage. It's like it's literally like it's like, here is your 28-story steel moment frame structure. Is the number of bolts required for the top flange of the 7th story in the exterior bay needed to transfer the tensile force? 7 bolts, 21 bolts, 12 bolts? No, it's not even that shenanigan-y. It's like 10 bolts, 12 bolts, 14 bolts, 16 bolts. And then they're like, you have your dry erase sketch pad that's like, it's like 6 inches by 6 inches. And you're just like, pi r squared over, and you're just like, phi rn equals 36, 10. Moving on. It's just nothing that you would do in real life. Oh, and then by the way, they're like, yeah, this one's like we expect like all of these rows of calculations in order to get the answer, and you have 3 minutes to answer that. Go. And then your PDF is over here, and it's just like not loading. It's a great time. Dark memories of that time. Can we learn new software before getting a job? I mean, if it is required for getting a first job. Frank. Seems like Revit is a good one to have on your resume. Yep. April depth sections will have additional 30 minutes each. Okay. It's helping. It's going in the right direction. Can you tell me or explain how can I make structural calculations of vertical loads report for 30-year steel-framed wooden wall building for the permit? Vishnu, I go talk to Coot over in Engine Tips. We're not going to unload that one here today, unfortunately. But what we are going to unload after all of this time. All right. It's the tier list. I threw this together a little bit. And this is just about all of the core classes for civil engineering. At least that I had to take. Not all of these, but that I had the option of taking back in college and all the way in 2014. So let's get into it. Can I zoom this in a little bit? How's that? There we go. All right. And anyone chime in at any time. We got all the way from year 1, freshman year, all the way to graduating. 4-year degree, bachelor's of science, civil engineering. You get a taste of everything, just about everything in here. Geotechnical, transportation, environmental, structural. So everything's basically weighted in here. But we're going to break them down together here. S tier, we all know, is the creme de la creme, is the best. A through D are self-representative. All right. Intro to civil engineering, I think, is that classic, like, you're feeling it out. You don't know what to expect. They give you that speech of look to the person to your right, look to the person to your left. Only one of you is going to survive because there's like a 33% pass rate to people to get to graduation. So they like scare you a little bit, make you sweat, but also show you all the fun that you can have, but likely won't have. We're going to go with a solid B on that. Calc 1, I mean, no diffie-qs. That's, what did I call that? Calc 4 is diffie-qs. Calc 1, Calc 2 is, what was the Calc 2 was the one with the made-up equations, the, like, backwards equations. Calc 3 was, non-linear. No. Multivariable. Calc 3 was multivariable, and then Calc 2, integrals. Integrals. Calc 1 is just your calculus. Like, I'm going to say let's flex on that a little bit. I think that's just a great time. We're going to go with an A for that. Chem 1, freshman year. I liked balancing equations in Chem 1, but me and chemistry just never got along all that much. I'm going to throw it into a C. Physics 1. I liked physics. I think physics 1, Calc 1, just nice little 1-2 combo there. I don't think you're going to go wrong. And I think if you do enjoy both of these, I think you know that you found yourself in the right kind of field. Chem lab titrations can go right in the trash. Physics 1 S tier. Really? I'm a keep it 1 for now. Physics 2 got a little crazier. I'm going to actually drop Physics 2 B, because I think Physics 2 is nothing in comparison to Physics 1, but I just don't think Physics 1 is S tier material. These are still just like your core classes. Got to know them all type of thing. Got to catch them all. I don't think these are particular. They're kind of in order. Chem 2. Physics 2 is trash. Alright, so it ain't just me. I'm kind of... Chem 2 is going to go in the D. We're going to get our first D here. Straight duty. Chem 1, maybe. Chem 2, horrible. Now here's our first real one. Get you interested in civil engineering. Engineering measurements. What are we... You know, you're taking out the topo stations. At least I got to. And you had to do like an exercise to map out a part of the campus and get back and make sure. And you had to be within a certain amount of accuracy, and depending on how close you were in accuracy, gave you your grade. So the closer that you were, the higher your grade was. The further off that you were, the lower your grade was. It was actually kind of dope. I really liked that challenge. But we had to use a topo station and go around a building and get back to the original benchmark. That was fun. And then, like, you know, you have your little Write in the Rain book with all of your data, and then doing the like back and forth calculations, moving up in elevation, moving down in order to get back to your datum. That was fun. I'm going bang. Survey class. Okay, yeah, engineering measurements, survey. Juan's saying Physics 2 S tier with the magnetism. Juan, you're speaking more mechanical engineering in my mind, or astro. Or aero, not astro, aerospace. Am I picking that up from you? My partner kicked the plumb bob after 3 hours and I nearly killed him. Oh man, that's a core memory. We had the fancy ones, so like the ones that you actually use out in the field with the laser going down. You have the plate and you slide the plate around and you shoot the laser down. That was dope. And it's like a $25,000 instrument that you're holding in your hands. You're freaking out about it. Another, is this too harsh? Too harsh? Statics? I feel like that is a fundamental S tier class. More so, though, here, pump the brakes on this one, though. Focusing on structural engineering. Hence, that's why, for me, S tier. Environmental? Dog shit. Geotechnical? Beer in a can. Structural? S. Yeah. Easy S tier. All right. That's what I'm talking about. Which to Charles, to your point, very much to your point. Where are we at here? I saw it. Hold up. We're looking for that. Where is it? Oh, it's the last one. Structural dynamics, statics versus dynamics. and that's coming from a structural engineer. Structural dynamics sucked. Drop it in D? Yeah, all right. Things moving around. I don't know, man. There's some witchcraft going on there. But you do get more comfortable with it, I think, if you're out here doing seismic design, because there's principles rooted in structural dynamics. You want your structures to be moving with the earthquake for a better performing system and all of that kind of stuff. But it just... You had that mass on the popsicle stick just waving back and forth, or you had the little carts with the springs and the wheels. Man, hated those homework assignments. No, it's so funny. My professor was fucking based in structural dynamics. He was already retired, but they had him come back because they couldn't get anybody to teach this class, and he had taught this class for ridiculous amount of years. And so he comes back out of retirement to teach us. And this is master's level. I took this as my master's, actually. And he was so cool. He did his best to just, talk about the subject and not just, be super vanilla and, here's the homework assignment and, not really engaging with the class. He did a good job of rooting it in concepts of the real world, and less so about, the number crunching. Still did the number crunching, but he made a bet one time. He was like, all right, there's 8 of us in the class. And he goes, all right, you guys don't have to do this homework assignment, but it is going to be due. And I am going to allow you to take the risk. He's like, I'm going to collect one homework assignment from somebody, and I'm going to put everybody's names in a hat, and I'm going to pull one of your names out of the hat. The person that I pull out of the hat has to hand in their homework assignment, and I'm going to grade it. So, 1 in 8 shot kind of thing. I told him, before, when he determined that, I said, I am telling you right now, I am not doing this homework. I'm taking the risk. No homework for me. What does he do? He pulls my name out of the hat. And he had, he did all the names. They weren't just all my name. He pulled it blankly. He showed the other person that was holding the hat to be he swear to God, he's like, I didn't do this on purpose. And he nailed me. But we all just laughed about it. It was a lot of fun. So I say all that, and that's going to get structural dynamics out of D and into C. Calc 2. I'm going C. I'm going easy here. I'm going Calc 2, Calc 3, Calc 4B. Big Pencil's got that dynamic flex going on. Big flex moment. I like that. Is this, am I out of bounds here? I don't think so. I think it's that easy. And I don't mean easy as in the class, because I struggled. Calc 2 is a whole different world. Those Calc 1 days of just ripping problems and knowing how to do everything, right into Calc 3, big punch in the dick. No good, no bueno. Struggled a ton. Studied so much to get 60s on my exams. It's going in the C. But I felt like I at least had some confidence with Calc 2. I felt like I was understanding topics. And I felt like I was preparing for exams. And then I wasn't preparing for exams. Remember it was like you write your equation and like all of the homework or all the exams were like, don't forget plus the constant. Is that what it was? Constant? Is that? So it's like you write out your equation. You're like, x squared plus b plus 2y plus c. And it was like such a big ass deal to put the plus c at the end of it. That's all I remember from Calc 2. Calc 3 was my hardest class in college, full stop. Almost failed it. I ripped up the final exam for Calc 3, which got me a C- in the class. Like, I think I got like a 90 or above on my final, and the final was worth like 35% of the grade. I was that far in the shitter for Calc 3. I thought it was so hard, and I took it as a summer class. I wanted to speed up a little bit or not have an as loaded schedule during the actual school year so I could have a little bit more fun or so do other things. And I lived close enough to college that I was like, oh, why don't I just take a summer course? And they were offering Calc 3, so I decided to take it. But oh my God. And so I got a C-, and that was the only class I was taking. How bananas is that? Calc 3 was better than Calc 2. Yeah, those graphs, those like 3-dimensional graphs, I don't know, man. And then Calc 4, this is where the light shines back on me a little bit. And I did good in Calc 4. And I understood differential equations. I was sweating going into Calc 4 though, because I'm like, it just keeps getting harder and harder, and I need to get through these math courses in order to become an engineer, and it's killing me because the type of math that we're doing has nothing to do with engineering anymore, at least civil engineering. But Calc 4, yeah, DiffyQs was different for me. It was a great time. I think I got a B+ in it, and was never really stressing about it. Flew by in an instant. It was great. All right, let's proceed. Our next heavy hitter, easy S tier. Strength of materials, structural. It's your bread and butter. It's your trifecta. If we have our holy grail of structural, I mean, you got you got strength of materials. You know you got statics. What the other one is? We'll see. We shall see. Let us proceed. Okay, so this is one that I don't know if everybody has. We had a class called Programming for Civil Engineering, and it's kind of a blur. It's actually going to be a D. It was all about, at the end of the day, learning how to do What's that called in Excel? Like coding macros? Is that what it is? Wait, what's VBA? What's Visual Basics? Why does that pop up to me? Is this a thing? Excel VBA. I think this is it. Visual Basics, it is it! Yes! Learning Visual Basics, yes! And like doing code and stuff. I know it's not like real code, I'm sure. I'm sure there's plenty of other stuff going on here, but I still don't know what the hell is going on with this stuff. Yes. The whole class was just about this. It was more like a lab. VBA coding. Oh. So, and we had a terrible instructor. We had this class but used MATLAB and just created stiffness matrices. Interesting. Oh, terrible. Struggled in it. I don't think I got that bad of a grade. Just, I know that the whole class struggled. All of us combined were just like, bruh, I don't even know what the hell's going on. Now, it ain't statics. It looks like it if you squint your eyes a little bit. Statistics. Probability and statistics. I'm going a solid A. Loved me my statistics. Always have. Always have. Took it in high school too. Love me some statistics. Followed right into engineering economics. Love me some engineering economics too. Almost an S. Love it. And actually, for all you PE takers out there, you know that there's engineering economics on the PE exam. So I know you've been studying that. Make sure you got that down. You got all those tables. You understand all those tables, how to quick reference and get the values and then plug them into the equations. And it's like, what is it? It's like future. I can't even remember at this point, but engineering economics, like the class. It's a good time. And it does directly correlate to, eventually, materials on the PE exam. Future and present value. Thank you. Thank you. Yes, 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 yes. Future worth, present worth, all that kind of jazz. And since we're just on the topic, this one, I don't know why this one's in here, but it was on the list. Micro or macroeconomics. It was like a 101 class. You can either take macro, you take micro. I took macro. This really straightforward. Graph go up. You're with all the business majors. They're all sweating a storm, trying to figure out y equals mx plus b and all that kind of stuff. It was just not even that. It was just a linear graph. We'll go B. We'll go B. I took linear algebra instead of statistics, and I cooked. No, not by any means. No. Do I have linear algebra in here? It was... So, I almost did, speaking of how horrific all of my calc was, I almost decided to do a minor in math because all I had to do was take linear algebra and then one other class, and then it would have gotten me a math minor, which I thought was relevant at the time. And, you know, no disrespect to any math majors in here, any math degree holders here, but I thought I was so close that, like, I might as well snag it. But I ended up not taking linear algebra, and I heard it was kind of hard, so I'm glad I didn't. I remember my Calc 4 final exam, and I knew in my head that this was potentially, as long as I passed this exam, it was the last math exam I was ever going to have to take in my life. You know, all the exams after school. Withholding, but just like not straight math. And I started to sweat a little bit before the exam because I was like, oh man, this is it. You want to like realize that after the fact kind of thing. Math minor, I had the same thought process, then I ended up in real analysis 1 and wanted to die. We thank you for your sacrifice. Purdy, we thank you. You will... You're gonna be missed. Alright, gang, it's getting real. Thermodynamics. The first slap in the face on the civil engineering side of things. And this one I know is, at least for us, I was in a dorm with all engineers. And there was a thermodynamics class for civil engineers, and then there was a thermo class for mechanical engineers. And I forget what it was. They just like used different variables or what, or talked about different things, but yeah, thermodynamics, man. And you know what's funny? I enjoyed it. I liked thermo. So I'm gonna go. Unpopular opinion. I'm going A. Thermo S tier. Real Analysis 1 is a 400 level math class. God damn. Thermodynamics S tier. Wow. I'm holding A. I loved thermo. And you know what I liked more? Which is crazy. No, I didn't like it more. Both fluids and thermo were taught by the same professor, and he was a madman. He was off the rails. Crazy. But in a, like, looking back, in a good way. The man had no filter, and just, he had that, like, Rick and Morty, Rick crazy, like, white hair, legitimately. And the dude was built. I mean, the guy's like 70 years old, 65, 70 years old, and he's like 6'5", and he's just a unit. And he knows so much about thermodynamics and fluids. Oh, no. He had to teach fluid dynamics, and like one of the things that he told us in the class was like, look, I don't know anything about fluid dynamics. I only know a little bit more than you do, and that's not saying all that much, and then proceeded to teach the class. Like, it was funny stuff. He would do, we're going A for fluids. He would post solutions to his homework that you would then have to use as study material for his exams, but he would do it by hand, and it would be the craziest 8.5 by 11 sheet of paper. Like, it would be like one problem's over here, and then he changed direction to another problem here, and then like they're all clumped together in no specific order in his crazy handwriting that half of it you couldn't read. Then he posts it on a bulletin board during a specific time slot behind this glass so that you couldn't get to it. So like everyone had to take photos, and it just, he was so old school. And I don't know if he was just screwing with us on purpose or if that's just how he did things. But laminar flow, in case you want to know, I still got it. Laminar flow, turbulent flow. Come on now. Do we? Come on. I think we all know. I think we all understand. Very clear. I think it's our third missing piece. Which forms the Holy Trinity of structural engineering. Am I wrong? I mean, here. Where am I? There it is. That's what a lot of it boils down to. If you're strong at these three things, Or if you just really are passionate about these two things, if these scratch your itch and you really enjoy the process of learning these subjects, stick to structural engineering. Just that is a strong indicator with now the years that have gone by for me in the professional field. Really strong indicator. All right, some of our electives are slipping in here now. Can't all be structural related, right? Transportation systems. Transpo was fun. I'm gonna go B. Simple. Believe it or not, I at a time was torn. You know, it was like a 70-30. 70% structural engineer, but 30% of me, I was warming up to transportation engineering. I thought I might go that route. Maybe the closest it had been is like a 60-40 split, still in structural engineering favor, but most of my courses that I took were structural, and then if I had to fill any more, it was transportation related. I thought that was a lot of fun. Environmental engineering. We were working with, I can't even remember what I did in that class. I remember this though, water resources engineering. This class was also a D. This one stunk. This one was like, if I'm remembering it right, was a blend of chemistry with like titration or like cleaning water with chemicals and calculating silt deposits and basically making like wastewater treatment plants to some degree. Although I think there was another class. Hydrology, water and wastewater, maybe that was it. Water resources, they're just, get them out. Get them out. Everything environmental related, it wasn't it. It wasn't it. I wasn't doing it for me. And many of them I didn't take. They were the last on my list. I only took the ones that were required. And I think this one was like intro to environmental engineering. So, and then I forget why I took like water and wastewater, but maybe I had to take something else to fill it as well. All right. Oh, what did we choose for our, what's worse here? Misplaced anchor bolts or unsanctioned hole in the steel beam? I'm gonna go anchor. Oops. What am I doing here? What did we end up with? Hang on. Misplaced anchor bolt is worse than a hole in the steel beam. I would agree with you. Collectively, we got a 65-35 split here. I would agree. This sucks. Holes in steel beams, we can always strengthen, right? Especially if it's steel. Steel's the easiest. Let's end that sucker. Oh, I got the freebie. Freebie elective. And I took wood design. It was really boiled down. And believe it or not, there was no wood or masonry classes available to civil engineers. They're just, they didn't have professors or they didn't have classes to take on those subjects. So the only one wood related that I could get my hands on was actually through the construction management, what do you call that? Degree path. The School of Construction Management, I think it was something like that. Which there's a ton of cool people over there pursuing those degrees. That was also a really cool degree that I think looking back, I would have interest in as well. And obviously that's on the contractor, more so contractor side of things. But they had wood design in their core curriculum for some reason. So I requested to take that class and asked if that would cover the requirements that I needed to cover. And they were like, yeah, that's good. So me and my buddy took it. And man, we're thrown into the fire of wood design. That's for sure. Learning it for the first time, but we took it slow. It was like half and half. It was half learning about actual wood construction, like the methodology of it, terminology of it, and then a little bit of numbers based. So really wasn't a lot of engineering involved. We talked briefly about like the adjustment factors and how those plays into things, and like the process behind how you would do calculations, but never actually doing that many calculations. But then the second half of the class was a lab where we had to span a certain distance with a certain amount of 2x material, a certain amount of plywood material, and a certain amount of nails and screws. And you had to build something to span that distance, and the team that could support the most amount of it's going A tier. That supported the most amount of load was like deemed the champions, and that was cool. So basically, you made a wood truss at the end of the day, and you used like the plywood. Where are we? You made. I think I made. It might have been a box. Made something along these lines. I think we had scrap left over, so I was like, I might have done something like that. And this is one of the few times I actually used an analysis software, because I had enough knowledge to the point to be able to do something like this, what I thought was confidently. And I think it was loaded right in the middle, so I think there's something like that. Or but then that was all the 2x material, then used the plywood as your little gussets, your little side plate gussets. Kind of stitch it, and we glued those and stitched all that together, because there wasn't enough, wasn't as much as you would think in terms of having an abundance to really do everything that you wanted to do. So you had to be selective with it. And then we had a couple of timber screws and everything like that. So I forget where we put all of that stuff, but at the end of the day, we sized everything that we needed. I put the template into AutoCAD, so then we could be like, all right, we have our 4x8 sheet, and we need this shape, and we need that shape, and we need this shape, and we need that shape, and we need this shape, and basically proved that we had enough material to make all of the shapes that we needed. And then we went into the shop and we cut them all out, stuff like that. It was fun. That hands-on stuff is awesome. Ever taken a drawing class? What are you trying to say? You talk about these? You saying that these are bad? Where is it? I think it looks pretty damn good. No, you're probably talking about like drafting classes. Oh, I didn't put that on here. That was another elective. Took a AutoCAD class. It was the last time that they were offering it, believe it or not. Oh, there you go. Drafting class. Yeah. Yeah. Last time they ever took it. Or ever gave it. And I had a lot of fun. Soil mechanics. Soil mechanics was difficult. I'm gonna put it in a C. I was paid 200. Yeah, I think that's what they did. They switched up, so they retired AutoCAD as an elective, and they brought in MS Paint 212. So that one, they wanted to push everybody a little bit harder on the drafting side of things. Although I feel like there's still engineering students coming out of school who haven't used Revit, and I'm like, yo, guys, teachers, professors, schools, you got to get on this Revit thing. Like, just about everybody uses it. Yeah, soil mechanics, difficult. I thought it was fairly difficult. And soil mechanics is also something that you study a good amount for the PE exam as well. So can't skip that one. Engineering writing. Do you guys have this one? Anybody remember this? This came about junior year for us and was a bitch of a class to get a hold of. They only had like 1 or 2 classes and everybody had to take it. And so there was a huge like log jam of getting students to get into these classes and get through them. But by the time that we got there, they, for some reason, had figured it out and brought in teachers or professors from the outside and taught a bunch of classes. So all of a sudden there was an abundance of engineering classes that you could sign up for and take. So our guy was really chill. It was a good time. He didn't take anything too seriously, and he sort of was an English teacher and like kind of learning about engineering writing himself. So it was a learning experience for everybody. I'm gonna go B. Concrete design. All right, step back. We ready? Oh. Yeah. S tier. Steel, though, I'm gonna leave it at A. Is that? I'm debating it here. No, I think they're both gonna go here. I don't know what it was. Our teachers were pretty good. They were enthusiastic. They knew a lot. I think they stay put there. Concrete S tier. I know. Maybe it does stay put. Steel ain't S though. I know that. Advanced concrete, I will go S tier. I had a dope professor for that. That was a good time. I learned a lot in that. Advanced steel, I'm also gonna go A. And I like steel. I thought I was much more of a concrete guy towards the end of school. And then as I got into my professional years, I did a lot of concrete at the beginning, but then shifted over to steel. And now I kind of have this like reversal where I'm more comfortable with steel. Blasphemy! Yeah, I'm holding strong. This isn't nowadays. Nowadays, they'd be up here. This is at school time. This is in college. They're gonna go down there. If these are just subjects in general for structural engineering, you just bet your bippy they're going up there, but not today. Ain't gonna be today. Okay. Steel felt easier than concrete in college. I know. That's what all of my friends said. For some reason, I didn't feel that way. I was getting tripped up in steel design in college. I couldn't quite wrap my head around the steel manual, I think was more my problem. All right. Let's see. Ugh. Let's get some. We haven't been chatting about transportation. Intro to traffic, or sorry, not intro, but traffic engineering. This is more of an elective. Oh, we did do transpo systems. I would probably, I didn't take this, but I bet you this is B quality. ITS. So Integrative Technology Systems, I think is what it's called. Anybody take this? My buddy does this nowadays. He's a transportation engineer, and this is like his main focal point for his career now. I think this continues to grow and grow and grow because as technology gets better, tracking more data and all that kind of stuff and finding more patterns and figuring out things. So that's my hunch anyway. I think it's also probably a beer. It's beer. B. It sounds cool. You know, I'm going to go A. Didn't take it, I know, but I think that sounds like a cool subject. Did I have pre-stressed concrete? I did not. The closest thing that we had to pre-stressed concrete, which I know you're going to be like, that's not that, was bridge engineering. I took intro to bridge engineering and didn't have to. But my friends and I decided to, and that was a horrible mistake. Bridge engineering, it's close to a D. For those of you who don't know, bridge engineering was what inspired me from a very young age to want to be a structural engineer. I loved bridges. And then as soon as I started learning about bridges, or at least through this class, very quickly didn't want to work on bridges. It was just a bad time. It was difficult, but it was more confusing than anything, and I don't know if it was just the style of teaching or the lack of time that we had, but it was a Debbie Downer. It wasn't a good time. Now when I got more inspired to do a bridge design after studying for the SE. So studying for the morning portion, bridge problems are on the morning breath portion of the exam, both lateral and gravity. And there's a lot of them. It's not something that you can just roll the dice and go, whatever, I'm going to guess on those and I'll just dominate the building portion because that's the exam that I'm taking. No, for the morning portion, you have to be able to pass a good amount of the bridge problems, otherwise you're not going to pass. So it forces you to get into AASHTO and really dive in and know what you're doing. And some of the example criteria or like practice problems that I had, some of the booklets and stuff were really great. They were really in depth, really clear, and made sense. And from that point, I was like, oh, I kind of like this again. This is kind of cool. So I'm hoping a bridge crosses my path, no pun intended, in the not too distant future, and I can kind of get into that industry a little bit, or get into that trade, get into that design pocket. School, though, is a big fat dookie. Earthquake engineering. Oh, to come full circle. How my college me would look at me now. I didn't take earthquake engineering because I was too scared to. You got me. That's all. That was it. I didn't think I was smart enough. Earthquakes, man, ground moving, shaking, having to design for that and figure out what that means, as opposed to the wind blowing. The wind blowing on my face with some amount of force, that's all you got to do for wind. Straightforward. No. It would turn out years later that you realize that there's so much more gray zone with wind design, so much complexity with wind design, and designing for earthquakes isn't horrifically terrible. Once you start doing it, it becomes pretty straightforward for the most part. Just keeping the unique earthquake resisting systems to the side. Base isolation, modal analysis and nonlinear analysis, and all tuned mass dampeners, and we're talking about a little bit of dynamics now, but those things aside, it's really not too bad at all. But I never took it, but I'd like to take that now, if I had the chance again, to tell myself to have the confidence that you'll survive. I'd probably put it as an A. We're coming down to the finals. This one is so New Englandy, I feel like, but I took it. I took it as an environmental elective, and I dodged all the other ones that probably made more sense. Design of fish passages. Can I get a W in the chat? Can I get an amen in the chat for some fish passages design? They're a big thing in New England, and I don't even know if they really work all that well. I know I'm probably not supposed to say that, but we had a professor come in. He was an outside guy, and he was basically just a professional engineer who designed fish passages. So it was cool to learn real world experience from him. I'm gonna go B. It was just cool overall. Having to run calculations or learn about people who derived these calculations that are all dependent upon fish behavior. And it's not like you can ask the fish what's going on. You're like, oh, does this amount of flow like feel good to you, or does the choppiness of the current, does that mimic your natural environment and make it so that you want to come over to this strange passageway instead of just being dumb and like running into the dam and not going anywhere and dying? All that kind of stuff. It's like, man, who figured that out? Who spent the time to turn the behaviors of fish into equations, mathematical equations? Fascinating. Public transportation. This is another, obviously, transportation one. Didn't take it. Public transportation, I feel like, could be cool. I'm gonna go B. I have a soft spot for transportation engineers in my heart, as you can see. Environmental engineers, clearly not so much. Foundation engineering. B. Almost an A. But it's going to be a B. And then we come down to the beast. Finite element analysis. Hard class. And it was right at the end of my career, my college career. Man, was it difficult. And the guy who taught it was a tough teacher. He was really nice though, but man, this was a difficult subject for me. I'm gonna go C. There it is. There it is. I'm gonna screenshot that. It's going on the community page. Beautiful. And there she is. Oh my god, it's almost 9. Dang. Maybe we're not going to be doing any detailing today. I think we're going to wrap it there then. What do you guys think? Any changes? Any major overhauls here? What's the difference between the PE structural and breadth and lateral? Hey, Gear, no problem. No problem. Hey, before anybody goes, even if you're already gone, that's fine. Leave a like down below. Highly appreciate it. If you can't this time, I get it. You got to hoard the likes. You got to keep for next time. I totally get that. If you've been in here, you've been chilling, you've been hanging out right before the big U.S. holiday, 4th of July tomorrow, consider subscribing if you haven't yet. Connect with thousands of other engineers from around the world. Civil, structural, mechanical, aerospace, all of them. I don't know who's in here, but probably more civil than not. But you never know. You never know who you're going to run into, who you're going to meet, who you're going to connect with, and advance your careers together. If you're already subscribed and you want to take it a step further, consider becoming a channel member, supporting the channel any way that you can, but you do not have to. I always and forever will keep this channel free. So don't think that you need to, but if you feel so inclined, you can join the Peruka gang, help us out. But that'll about do it, man. I appreciate everybody coming in today. This is a good time. This is a nice little change up, I think. I like this a lot. It was fun. What kind of projects excites you the most? I like a good building. I mean, I do a lot of buildings. It's all that I do for the most part, but I love me a mass timber building nowadays. Is that a cop out? Is that like, oh, of course you do? I really do though. They're great. And when they go up, they're in construction. You get to walk through them as they're being built. It's a different feeling. The spaces that they create with the structure, with the material, is just different. And there's a reason why they're growing in popularity, at least out here in the Pacific Northwest. A Discord channel for this, a Discord chat for this channel would be sick. I have Discord now. I gotta figure out how to do that. I should do that. Discord would be awesome. You guys feeling Discord? Should we do that? I'll throw up the last poll for a couple of you still in here. Give me that. Give me that. Yeah. Bang, we started. This will be the last thing for tonight. Bang. Show me what you think before you head out. It's the last request tonight. Or honestly, yeah. I mean, hey, we got the 100%, so I'm fine going for it. That sounds great to me. Oh! But alright, though. Chat, team, enjoy your holiday weekend. Really, take a breather, whether you're studying, not studying, thinking about studying, have a deadline, don't have a deadline, spending time with family or not. Take a second for yourself, relax. Proud of everything you've done to date in your engineering career, no matter where you are, no matter if you're just starting or if you've been in it for a really long time. Proud of you. You've done some great work. Just keep staying curious. Keep getting after it. Keep trying to pursue doing great work. That's all that we strive for on this channel. All right, gang. Peace, if I can figure out the transition in a smooth manner. Probably something like... Is this still on? Hello? Ah!